Hello everyone, welcome back to another LeetCode problem. Today we're doing problem 53, maximum subarray. It's a medium rated problem and it reads, given an integer array nums, find the subarray with the largest sum and return its sum. Now what does this mean? Let's start off with this example. Negative 2, 1, negative 3, 4, negative 1, 2, 1, negative 5, and 4. So for given array of elements, which are all integers, we want to find a subarray with the maximum sum. Now a subarray just means an array within an array, something like this or this, and the sum would be all the elements added up together. Now in this case, the answer is, well, what is it? It's 6, and that's because if we look at the subarray here, 4, negative 1, 2, and 1, this ends up being 4 minus 1 plus 2 plus 1, that's equal to 6. And if you were to check any other subarray, you'll always get a sum that's smaller. Now, I will show you two ways to solve this. Well, the second way is basically the same as the first way, but it is more memory efficient. The second way is actually called the Kadane algorithm. I'm not sure if I'm saying that right, but the first approach is to use dynamic programming. How does dynamic programming work? Well, dynamic programming works by breaking the problem into subproblems. Okay, now how does that work here? Well, let's use a smaller array. 5, 4, negative 1, 7, and 8. Okay, the first thing that we're going to do is create some memory to store the answers before. And that is, we're going to call it DP for dynamic programming, and it's going to have the same exact length, and it's going to have default values of 0. Okay, now how does dynamic programming work? What do I mean by breaking it up into smaller problems? Well, what I mean is we're going to iterate this through a for loop that goes from the first element to the right, and let's say we are at this 5. We're actually going to break it up like this. We're going to pretend like the only array we're looking at is this 5. Okay, that makes sense. So then from there, we will see what is the biggest sum in an array of 5. Well, the thing is, if the array only had one element here, like this subarray here, 5, well, this has to be a 5. So by default, our very first element, no matter what this is, this could be negative 100. It's still the maximum sub, but we would have to make this negative 100. So as a base case is just the smallest subproblem that we can get to, and we could just define the answer right away. We have to store the very first value as whatever the very first value in our array is. So these two are actually equal. So that's the base case. Now, what do we do from there? Now we iterate to the next one. Well, we don't iterate to the next one. Technically, we start our iteration at the second element 4 because this is just set as a base case. Okay, well at 4, we're breaking up this subproblem into 2 parts. Okay, and from here we can check. Well, we want to update this value, but we want to check we want to add to nums. Basically, do we want to add this previous value or do we want to add on 0? Adding on the previous value means that this becomes the subarray. But let's say this was a negative 10, for example. Well, it's negative, so actually we would rather add 0 because this subarray by itself as 0 plus 4 is bigger than 4 minus 10. So that's why we actually check the max between 0 and dp of I minus 1. Okay, well in this case this was a 5. And when we update it, well, we're checking the max between 0 and dp I minus 1. Well, the max here ends up being 5, but we don't just update this with a 5. We're extending this array. So what that means is we're actually updating it with a 4 plus 5, which is 9. So here we go dp at I plus the max between dp at I minus 1. Okay, So that's if the array was only the 5 and the 4. Let's move it on to here. Now the subarray looks like this. Okay, we do the exact same thing. We check the max between 0 and dp of I minus 1. 9 is greater than that, so we add them together. Minus 1 plus 9 is 8. Okay, and now we move on to the 7. We're at here now. Well, 8 is greater than 0, so we use the 8. So 8 plus 7 is 15. That's fine. Now we move on to here. Difference between 15 and 0. Well, not difference, but 15 is the max, so we use 15. 15 plus 8 is 23. And then from there, we just pull out the maximum number from here, which ends up being 23. Which if we check, yes, that is correct. Now, why can we do this? We can actually do this because, well, these are just breaking up all the subintervals into all the subarrays. We're breaking up each array into subarrays, and from here we're getting the maximum between each possible one. And if a subarray is like negative, well, we're actually just leaving that behind by checking the max between dp at I minus 1 and 0. And since we're only asked for the sum, we don't actually need the actual indices of the subarray, so we can actually just return that number. Now this is fine, it's very efficient. It has a time complexity of O to the n, but it also has a memory usage of O to the n as well. Now we can do better than that because we're only checking the value before, right? So we don't really need to keep track of every single one. Now how do we do that? Okay, well, let's rewrite this. 5, 4, okay, 5, 4, negative 1, 7, and 8. We will store, instead of returning the maximum of our dp array, we don't have a dp array anymore. Now we're just going to have some max sum, and by default we're going to store it as negative infinity. Okay, just because we want we want it to be at a number where it's guaranteed to be smaller than any other sum, which the only number that guarantees that is negative infinity. Okay, we also want a variable current, and this stores the value of the sum of the current subarray that we're looking at, and we want to start it off as 0. Okay, now we iterate from the beginning this time, and all we do is add on this num to 5, right? And then from there we check the max. We check if this max sum is currently holding a number that's bigger than negative infinity. Well, it's not. We want to store the maximum between these two, which in this case would be 5. So we update it, and now we move on to 4. Update our current. Oh, 9 is greater than 5, so we use 9. Move on to negative 1, 8. Now in this case, this did make it smaller, so we're not going to update our max sum because we know that the max sum of this subarray is greater than this one. So for now we're going to hold on to the 9. Then we're going to move on to 7. We're gonna add 7, not replace it by 7. Oh, 15. Okay, move on, and this becomes 23. Now we return this. Now this is just checking the subarrays that are like this, right? And so on, that start at 5. But what if let's say this was a negative 10, and including it in our subarray only lowers the sum. We want to skip it. We want to have a subarray like this. Okay, well, if we were to do this and restart, just reset our numbers to negative infinity and 0. Well, we do the same thing. We add it to negative 10. The max sum would be negative 10. But now we know that carrying this negative 10 only decreases our sum. So we want to switch current back to 0. And we check if current is less than 0. Then we want to update current to be back to 0. So in this case it is. So we go back. And now if we go on, add a 4 here, comes a 4, go on. This comes a 3. We don't update it. 7. Now we do update. Move on to here. Just 8. Update. Update. And we just return whatever the max sum is in the end. And again, this is O to the n, but we're using constant space now. Yeah, so that should be the most efficient solution. And let's head over to LeetCode and see if we can code up this solution. Okay, now over in LeetCode, again, we want to start off with creating a max sum variable. Now we can use the float operator and just type in negative infinity to use negative infinity in Python. From here, we want to create our current, which is equal to 0 by default. And that's all the variables we need. We want to iterate through every single number now. The first thing we do is add that number onto whatever current is, set max sum to the max between its current value and current. And then from there, final check, we want to check if current is actually below 0, because if it is, we want to reset it back to 0. That's everything. We just return max sum. If we did everything correct, we should be able to get the correct solution. There you go. Thank you guys for watching. I'll see you guys in another LeetCode problem.